we are entering in our 6th week of build season, which is kind of a scary place to be, right? Because we're getting closer and closer to competition. We're trying to get stuff done. One of the things that we've done differently this year than years in the past is we've been very, very heavy on the 3D design up front, and then we're going to start, building everything as we get that 3D design done. What that means is we're kind of tail end building, and it's a little bit nerve-wracking. So today what we're working on is actually just running the machines, getting all of our parts machined, all the metal drilled, everything we need to put stuff together based on the design that we've had before. And so you'll notice the build site's not as busy today, and part of that is because we only have the people that are working on machining things in specific, very directed projects.
So here we have our V-Lock CNC. We cut out of metal. We do some wood for doing prototyping, and then we also do sand.
Basically, for me, I'm doing more CNC stuff with Joseph. I'm doing whatever metal that needs to be cut today. Any tap bars, hex shafts, stuff like that, and just finish up anything that we need to finish.
A lot of today is just going to be machining, getting parts cut out that we need, and now we're kind of at a stop, and we can't really build anything more because we don't have our parts that we need. So we're kind of cutting out the parts that we need right now.
Yeah, that's good.
So drill down those holes.
Yep. Right, take it up. So once we have all of our holes cut out, we need to take a couple screws, and if there are any drill holes, we just take our screws and put them in so that once we go to cut the piece out, it doesn't move and mess everything up. So we just take a couple screws and throw in here. So our bit was either going a little bit too fast. Yeah, I think it was going too fast, and it got way too hot. And so what happened is as these shards were being cut off, they started welding to the bit, which means that it's not going to cut right.
So we go step at a time, and this might have been a little bit too thick of a cut.
Aluminum is really weird. It's a soft metal, and you wouldn't think about metals being soft or hard, but with aluminum, if you don't move quickly enough, if you take cuts that are too deep, what will happen is that aluminum gets really hot. So what we're doing is we're always trying to fight the balance. If it gets too hot, then it starts to, the chips that was clearing out as it's cutting, start to actually weld onto the tip of the bit. And it makes it to where it's cutting jagged paths and things that look really, really rocky. And so we're always trying to go fast enough to clear those bits. You saw somebody spraying air against it, right? So they're spraying air against it to clear the bits. We're spraying, lubricant to try to keep it cool as best we can. So it keeps that temperature right under the amount that it needs to be, so that we don't have to worry about it messing up our whole plate. This is something that we can't do yet at our STEM center because they were using something called a Tormach CNC mill, which cuts much thicker aluminum. So you can imagine this is basically a 1/4 inch piece of aluminum, and this is what, an inch?
Yeah.
An inch stock of aluminum. And so it just kind of able to work and do much better. But you see this gorgeous piece.
Screws back out. Okay. We have us a new piece. So once we figured out it was going too deep, then we moved it up a little bit so it wasn't going as deep, and then we cut everything else amazing.
What we have to do is basically we have to stay calm. We have to be able to not freak out that something broke and be able to figure it out on our own.
One of the things I think I said in the very beginning, in our very first video that we were working on, I said, we have to be able to fail often, fail quickly, fail hard, because at failure you learn what you did wrong. If you never fail, then you never learn new things. And so whenever they mess up, whenever a drill bit melts through aluminum, whenever we cut a part and it's too small or something's too large or we didn't think through something, it's the time we can stop, reflect, and learn more about what we need to do right the next time. And really, that's what this whole program's about. Again, I like having a competitive robot that works well at the end. In order to do that, we have to be able to have these processes in the very beginning of something's not going to work right. Let's do that now, get that out of the way, learn from it, and get better at what we're doing. So let's start off with what mentors are. A mentor is somebody who's an adult. They're over 18. Sometimes they've been part of FIRST Robotics programs in the past. Sometimes they haven't been. And they come work with us and our students and help them create the robots that we build. One of the cool things about mentors is there's not a specific pattern of, well, they can be involved this much or not this much, or they do this much work but not that much work. they're involved right hand in hand with our students in the entire part of the build process. What this means is that the knowledge that they have continues to build from season to season. And so when you have a mentor that's been, let's say, mentoring for 10 years, they have all this extra experience they bring to play when they're going to train or teach new people that are coming in that are the students. We're really, really fortunate to have a lot of mentors. We have, I believe, 12 mentors right now at the moment, and all of them come from different places. Some of them are teachers. Some of them have a lot of experience with engineering. We have engineering mentors. We have a mentor from NASA. We have all these people from different backgrounds that come in to give their support and help build as we go through the process.
My name is Gregory Field. I am an electrical engineering student at LSU. This is going to be my second year mentoring, but I've been in FIRST program since I was in middle school. I think FIRST Robotics really increased and encouraged me to do a STEM field, and especially go into engineering. I've always kind of been very fascinated with building things and programming things, but FIRST really gave me an outlet to be able to do that in a very competitive and practical sense. It really comes down to the competitiveness of it. I'm a very competitive person, and this gives me very much an outlet to kind of express that and be able to still maintain a healthy level of adrenaline and competition in a sense. It gives me a great satisfaction, but also, I mean, I love seeing the look on the kids' faces whenever we win big or whenever we go to a competition and they get to see the atmosphere for the first time. Just that smile on their faces really does it for me, and I just want to make sure I'm there to make sure they're having the best time possible.
In high school, well, my mom actually had a friend whose kid was in the robotics program, and that's how I was initially introduced to it. And I checked it out, and it just seemed really interesting to me, something that I wanted to continue doing. And so eventually, for the next couple of years, that's kind of how I got into that. Being a mentor to me means being able to not just impart knowledge, but also impart a love of what I'm mentoring in, so robotics, a love of robotics, a love of STEM, and also to give the students that I'm mentoring the tools to continue learning without my help or without my influence.
I got involved, actually I had a friend she was a year ahead of me when I was in junior high. She suggested that I try out robotics whenever I get to high school, and because her mom was involved in robotics and stuff, so I was like, okay, fine, I'll do it just for her. I went my freshman year for the first meeting and stuff. I really, really enjoyed it. A little more than I expected, I guess. And so I just kind of stuck around and did build, got into machining, and then eventually ended up being strategy captain and fundraising captain. I am a college student at LSU. I'm a senior in mechanical engineering. I'm graduating this spring. I think the biggest thing for mentoring is I obviously get to stay involved in something that I really love, kind of being able to give back to the community and the organization that gave me so much in high school and got me to where I am today. But it's also, I think it's kind of evolved more through these 4 years of mentoring, that I'm getting to see the growth in the students, and I don't know, feeling a part of that and feeling a part of the growth of the team itself, seeing from where we were our very first year, getting, a couple awards, to making a pretty good robot, but the robots today their league's better, and just in 3 years time. I don't know, it's just bigger than yourself, which sounds really cheesy. But yeah, getting to pass on the knowledge that I have.
I actually started robotics in 8th grade. My junior high had a program that I heard about that my algebra teacher was helping with, and I thought it'd be cool, so I joined the team. Joined the high school team when I went to high school, which was larger scale. And yeah, just kept putting more and more time. So now I go to LSU. I'm a junior in industrial engineering. It's not as boring as it sounds. I started in mechanical, and it wasn't really my thing. I switched. It was something that I always wanted to do. When you're on a team and your mentor comes, you're like, oh, I might like to do that someday. So it was kind of just the natural step for me. FIRST is just so, like everyone says, it's more than robots. It's just about, I've grown so much as a person from FIRST, and I want to help kids realize how they can grow from it and how it can help them in their life and in their daily decisions that they have to make, how they can become a better person and impact their world in a positive way, whether it's robotics or engineering or some other endeavor, whatever you take on.
One of my former students from Ponchatoula was on the Hammond High team. Their coach was moving up to administration. They needed a new coach over at Hammond High, so a couple of people suggested that I might be good at it, so they asked me if I wanted to do it. I said, sure. Sounded like a good idea. I love it here mainly because it's a great group of kids. The administration, all the way up to the school board, is very, very supportive of all of our programs. I liked coming here because we were the first team in the area, so it was a chance to develop and help start new programs all across the region. This year's robots are really unique. I know Coach Island may have mentioned it. The fact that we're picking up a very strange shaped object. A lot of the games in the past, if you're picking up something that's round or you're picking up something that's square, or one year they did frisbees, which was kind of interesting, but this is a very, very unique challenge.
I always explain my journey to robotics by saying that I have a degree in English and in history. When I got a job at Woodlawn many years ago, back in 2011, I asked if I would help with the robotics program because I had some experience with computers. And I was like, I thought robots. So I thought using small robots, Legos, things like that. And then when I got started, they said, no, here's a big robot you're gonna be helping to build. I had no idea what I was doing. From that point, it was a matter of trying to learn as much as I could as we go through. Fortunately, I had a lot of mentors that came along to help, and they taught me how to be a mentor, how to be a coach. I never coached before that, any sport, any other athletic activity, nothing. And so a lot of this was me building through that process. So I've been a coach ever since. And a lot of this has been, really getting excited about what robotics does and seeing the change that it makes in people's lives. One of the biggest things that I recognize is very little about the robot. I enjoy the robot part, but really the reason I'm a mentor is because it provides people a place to belong. And I know when I was in high school, that's what I was looking for. I know that a lot of the students that I've taught over the years, that's what they're all looking for, is just a place to belong, that they can feel like they're doing something, they're active in something, they're part of something that's bigger than they are.
Hey, that'd been fun for you.
So this is machining and building, machining and building, machining and building. We are trying to get all the parts that we've designed in 3D cut out. We're using our milling machines, our CNC routers a lot, trying to get all the holes cut out, get everything lightened up, ready to put together. And hopefully by the end of this week, we're gonna have actually our systems starting to come together as a whole. My goal is by next week, I want to get this whole robot to our programmers so they can start working on actually building the programming that's necessary to run the robot.
I'm part of the mechanical team and I'm the mechanical manager. And pretty much the mechanical team, we work on the construction of the robot, like different components of it, how it's built. We're the ones who actually assemble everything and put everything together for the robot. Right now, we're more of waiting for parts to be cut on the CNC, so once we get all those parts, we'll start using those parts and start building pieces that we need.
So I am the machine manager. I work mainly with CNC and all of the tools in the back shop. For anybody that needs help, they can come to me. In the shop, all we have this week so far is cutting the 3 plates for the vertical elevator and then working on getting bumper stuff cut out.
I'm the build side or either shop manager. I do most of the mechanical stuff. I'm the person that everybody has to go to before they can leave, like after cleaning and all that. I'm the one everybody goes to be able to do all the saws, like cut out the metal, stuff like that. Right now, I'm putting together our horizontal elevator for us so we can see how that's gonna look for whenever it's on our bot. Why I made this happen is I had to disassemble these first to be able to put this bar on because it screws inside of the elevator mechanism. And then I just did the same thing with the top bar. I took off these to be able to slide this through, put this back on, and then just put it on through here. And
We're good.
Once we get our other materials and all that in, I'm probably going to start putting together our prototype intake.
Let's say you're trying to make a 3D object. You're going to make an original sketch, you're going to thicken it, and then later on you can make more sketches on it and then remove parts of it, you know. But we have certain pieces that we have to interact with and certain goals that we need to do. Well, whenever you have those very specific measurements, you can have things exactly how you want them.
So basically on the electrical team is that we basically check on the batteries and stuff to where they're usable, they're usable, and to where we can like put it on the robot and we can prepare them for competition. And we also basically manage the wires that go into the robot, like such as motors and different other mechanisms that go into it, to where we put it on a board for the programmers so we can like all hook it up and like make sure the robot's working with all the electrical stuff.
My to-do this week is to finish up Hoverfly, rewire it to 4 gauge, and then finish all these batteries up to 4 gauge and the chargers. And I just finished the Swervebot today, so it's already ready to wire it up to go to get the belly pan done, but that's not coming until next week.
I don't know if there's anything that I would say I don't know about, but we're definitely still very nervous about having a very well-running intake mechanism to bring in this stuff. And like I've talked about all the way back at the beginning, picking up cones is just not easy. And I'm still watching teams on video struggle getting them the exact same way they want every single time. And it's the balance that you're trying to run, the sacrifice that you're trying to make. What's the best way of going about this? And eventually we're going to run out of time to make those decisions, and it just has to be what it is.
We're gonna have to cram a lot to try and get this robot done soon.
Took over at Hammond, it was somebody else's program, and here we got to start a lot of our own programs from scratch. So that was really fun.
How is it to work with just clowns
like Will and Ethan?
Yeah, just
these guys are just awesome, man. They always keep me entertained.